Okay, so suppose we want to find max or minimum of this function here, this quadratic function, 4x plus 160. Okay, and we can of course do the completing the square to find the max or minimum, the vertex form. But sometimes, that's not the easiest thing to do, particularly if this is an odd number here. So we're going to use a technique called partial factoring. Partial factoring. And let's consider f at x, just the first two terms, minus 2x squared plus 4x. Okay. So if we have a y is equal to f at x, okay, this part plus 160, right? So if I let f at x be this part, this original y is this. All this does to the function f at x, all it does, right, compared to this graph, the new y equals f at x plus 160, it raises the graph upwards of 160. Right? So compared to the original one, let's say, it just raises the graph up. In other words, the location, the x location, right? The x location of the vertex will be same on f at x, or the original y equals minus 2x squared plus 4x plus 160. Okay, so what that means is, we can just find the location of the x location of the vertex of this one. We can quickly do that by factoring. And that's the nice thing about taking the first two terms, because they both have x in it. Let's factor out minus 2x, and you get x minus 2. So the roots are 0 and 2, which means, okay, here the roots occur at 0 and 2, which means the midpoint is 1. So that means x equals 1, right? X equals 1 is the x coordinate of the vertex. To find the y coordinate, all you have to do is plug in 1 into this, okay, the original equation. Okay. Then it will give you the height. It will give you the y location of the vertex of this original function. So we have minus 2 plus 4 plus 160. So that's 2 plus 160. That's 162. Of course, this is a graph that's going downwards, so therefore we can say there's a maximum is equal to 162 at x is equal to 1. Okay, so note that we didn't have to complete the square at all. I mean, there's a lot of explanation here, but the overall process is actually much simpler.